All right, let's take a look at our Chapter 5 study guide here, get you ready for our test. All right, so this unit was all about our rational expressions. We kind of progressed into just being able to simplify them, to multiplying and dividing them, to later on moving into adding and subtracting. The biggest idea is just like we simplify, we learned back in middle school how to simplify fractions. Now we're just kind of taking a step up and what happens when we see, expressions in fractions instead of just numbers like we're used to. All right, so if we look at number one, anytime I see these things, we definitely look to cancel. But the second thing I definitely look for is, see if there's something I can factor. Okay, see if there's common factors that I can pull out. Well, n plus 7's in the top. That can't go any further. But down in the bottom, I have an 8n squared and a 56n. Well, I know 8 goes into 56, so I know I can factor out an 8. All right, and this has an n squared and an n. So this is the big reason, or one of the main reasons I feel like we have been factoring since almost the beginning. In the beginning we talked about how to find the GCF of different terms, and those kind of skills constantly should stay with us here. So the GCF out of the bottom is an 8n, and when I factor out 8n, right, in essence, we're going to take each of these two terms that are in the bottom, so 8n squared, and we're going to divide it by the 8n that we have as a factor. Well, when I divide this away, I'm just going to be left with an n. We didn't pull out a negative or anything, so the sign's just going to stay true. And then the second term I have is a 56n, and again, we're pulling out that factor of 8n. So what times 8n gives you 56n, and 8 times 7 gives us 56. All right, and the n's are going to cancel, so that's why the n didn't come with us. And then now we look at our rational expression, and we can see, well, I've got an n plus 7 on top and an n plus 7 on bottom. They can cancel, or if you want to think about it, going to 1. So one thing I really like this example because it shows that, notice how the 8n is in the bottom. Well, the 8n is going to stay in the bottom, but everything canceled away from the top. So don't put a 0. That's going to make the entire thing go to 0. It stays as a 1, right? Anything divided by itself is 1. I know we say cancels out, which kind of just a loose term for it goes away, but understand that there is a 1 that kind of hangs on to it there. So it looks like our answer is going to be C. Same kind of drill for number 2. There's no operations involved. It looks like we need to factor the numerator and then factor the denominator. Well, the numerator, I have a 7 and a 21. I know a 7 can get pulled out of that. So I've divided both terms by 7. I'm left with v minus, and then 21 divided by 7 is 3. So one thing we kind of discussed when doing these things, if I distribute this 7 back in, so 7 times v, 7 times negative 3 is negative 21. You should end up with where you started. And then I have a quadratic on the bottom. My a value is 1. If you want to think about the diamond, negative 21 goes up, excuse me, 4 goes down. It looks like I'm going to deal with 7 and negative 3. So my factors are v plus 7 and v minus 3. I told you since, almost day 1 with this, how important factoring is. I know it's stressed with my algebra 1 kids. Factoring doesn't go away. Your factoring skills have to be strong, and especially doing these things could be rather difficult. So now looking at my expression, I have a v minus 3 over a v minus 3. Those are going to go away. I have a 7 in the numerator, and I have a v plus 7 down. Now, one thing also to emphasize on, notice how when we cancel, it's always a multiplication. You cannot cancel when there's addition or subtraction, okay? So don't look at this and say, oh, well, the answer is 1 over a v, okay? That's not what you have here. You have you have an expression held together by addition and subtraction down here. You can't cancel that away. Only when we have multiplication, right? This was 7 times that value. These parentheses were held together by multiplication, okay? Only when you see multiplication can you cancel stuff out. So really pay attention to that kind of stuff. And, well, if we want to go ahead and answer, it looks like our answer is B. All right, number 3, very similar setup here. I'm going to go ahead and factor the top. I think I have n minus 3 times n minus 3. I know I'm skipping some steps. Again, the factoring skill, I'm just kind of assuming you know how to do it by now. So that's what it should be factored. Now the bottom, this actually presents a pretty interesting case. So notice how it's not exactly what we have in one of these parentheses. This is an n minus 3. This is a 3 minus n. And when this happens, you know, the signs are flipped. -3, +3, positive n, negative n. When this happens, what we can do is I can factor out a -1. So if I pull a -1 out of this bottom or down the denominator, well, -n now becomes a positive n, and +3 now becomes a -3. Okay, so again, if you think about distributing, -1 times n, negative n, -1 times -3, +3. Because what that allows me to do is it allows me to start canceling some things, all right? So we have our n minus 3 as our numerators, but in the denominator, I have a -1 and the n minus 3. So now we have those same terms. Now what that allows me to do is I'm allowed to cancel, but instead of a +1 like we're used to having when we eliminate, now we have a -1. All right, so I have n minus 3, I'm running out of room. So we have an n minus 3 divided by -1. Well, you know, anything divided by 1 is itself, but anything divided by -1, it's the opposite. So n divided by -1 is -n. -3 divided by -1 is +3. Okay, so I really like this example because it does bring in this situation of what happens if the terms kind of look like they're flipped. You know, if you're kind of presented with this, it's pushing you to factor out a -1 like I just showed you. All right, number 4. Again, let's look to factor. What's the biggest number that goes into 28 and 40? It's going to be a 2. 4. 4. All right, so if I pull out a 4, 4 times 7 is 28, so I have 7a plus 10, all being divided by 8a. All right, so there's nothing in the parentheses that cancel that like it normally happens, but notice I do have a 4 over an 8. Well, 4a's, we should know, simplifies to 1/2. So I'm going to write this 1 so we can see it, but I have 1 times 7a plus 10. And then the bottom, so the 8 now goes to a 2 because of the 1/2. So we should have 7a plus 10 over 2a. All right, so pretty much there when we factor that numerator, 4/8 cut down to be a 1/2. All right, number 5. Looks like we're just almost a basic fraction here. Remember when we multiply fractions, we multiply straight across. Or, I think, you know, the idea of this chapter is to look to simplify before we multiply. Now we can multiply these out, but then we're gonna have to do some simplifying in the end. It's typically easier to simplify first and then make the number smaller, so we have to do less in the end. So one thing that I noticed, this first fraction, I have 9 over 3. Well, 9 over 3 is 3, and b over b's are going to go away, or it's going to go to 1. Same thing with the other guy. I have 2 over 2. The b's going to stay, but notice where the b's at. The b's in the bottom. So the 1's going to stay up, and we can kind of complete the fraction for the other guy as well. So now we multiply straight across. 3 times 1 is 3. 1 times b is b. So we have 3 over b. And again, you could have multiplied straight across and then simplified. Sometimes it is easier to cut down those numbers. Number 6. This is an example of everything's being factored. You just need to understand how to kind of cancel stuff out. So what I'm going to start with, the same fraction. I have a over 5 and a over 5. Kind of going across, right? Remember, we can cancel out going across our fraction. I have a 2a and a 2a. When it's all said and done, it looks like I have an a minus 4 on top, and I have a 2 on the bottom. Looks like D has that for us. 7 presents a similar circumstance here. Again, I can go across, so I've got an x minus 2 and an x minus 2. Again, notice, look, we've got x minus 7 and a 7 minus x. Notice how they're kind of flipped, right? The signs didn't stay. So what we can do is I can pull out a negative 1 from this guy on the left. So I've got an x minus 5. And I'm going to pull out that negative 1. So I have negative 1 times 2x. And now what happens is this 7 minus x now becomes x minus 7. Because now this allows me to cancel these x minus 7s. And in doing so, it looks like we are now left with that x minus 5 that didn't budge from the top. We pulled out the negative 1, and the 2x is going to stay with it. So we have x minus 5 over negative 2x. They left it with the numerator. It doesn't matter when we have a negative with a fraction. It's not the numerator or denominator. It's the whole fraction that's a negative. So what they did is they put the negative in the top. In the numerator, they put the negative with the x. So it basically flips these signs. I don't like how they answered that, but understand that these guys are one and the same. Just really, that negative does get pretty tricky, so just be careful with it. I'm going to do one more multiplication with you. So those have the instance of when it's already factored, how do we cancel it out? These next two examples take on the form of, what happens when we have to factor with it. Number 8, the answer is A. I'm not going to go through it, but the answer is A. That's just to kind of double check yourself. Let's look at number 9. So that's factored, that's factored, that's factored. The only thing that's not factored is the bottom right part of this, but the A value is a 1, so we should be able to factor rather quickly. So I have a k minus 4 over k plus 2 times k plus 2. I could have canceled those out. And let's factor the bottom. So what multiplies to get 20 adds to get 12. I think we've got k plus 10, k plus 2. Yeah, that'll take us there. Okay, so let's start canceling. I've got a k plus 2 and a k plus 2. Yeah, it looks like the only thing that's going to be left is not a lot canceled there. We have a k minus 4 from over there, and then the denominator, we have k plus 10 times k plus 2. Ooh. And it looks like C is going to take us there. Cool. All right, number 10. Not too much different here, but notice that the sign is now a division. What a division really, emphasizes is, I know back in middle school you learned keep, change, flip, and that's kind of the only difference, is this second fraction is now going to be flipped upside down. So I have 1 over x minus 5. Now multiplying, all right, in this fraction, again, it's just going to be reciprocated. It's going to be flipped over. So this x minus 4 was on top. He is now going to the bottom. All right, so I'm going to factor this, what was a denominator, into the numerator. The GCF of those guys, it looks like it's going to be a 9x. So when I pull out the 9x, I'm left with an x. 9 times 5 is 45. All right, then we're going to look to cancel. I've got an x minus 5 and an x minus 5. 1 times 9x. It's just going to leave me with 9x over x minus 4. And it looks like my answer there is going to be an A. Almost there. Okay, a couple examples of addition and subtraction. Addition and subtraction definitely presumes a much more challenging problems, I feel. So let's look at them. So these first two should not be bad. Remember when we add and subtract fractions, the kind of the golden rule is you need a common denominator, right? Since day one when you dealt with fractions, the only way you add and subtract them is through a common denominator. Now if there's variables and expressions, nothing changes. The denominator has to be completely the same or you cannot add and subtract them. So if we look at 11 and actually 12 presents the same kind of issue, look, I have a 10n squared and a 10n squared. So they are the same. So when I'm done, we are going to have a 10n squared in the denominator. And remember, when we add fractions, we don't add the denominator. When it's the same, it stays. All right, so I have 3 plus m plus 2n. Well, you're just combining like terms at this point, and I don't think there's anything to really combine. So I have 3 plus m plus 2n. So this one is really just understanding, how adding and subtracting fractions work. This one really didn't have much involved. Again, this was just kind of rule following. 11, yeah, 11 should be B. Again, 12 kind of presents the same issue. The denominator is the same, so I'm going to keep the denominator the same. I have 4k squared plus 16k. Now the bottom, I have, the numerator, I'm going to rewrite it so you can see it a little bit better, but I have k plus 1 minus, now this whole thing needs to get subtracted from, not just the k because that's listed first, the whole thing is subtracted. So I have k minus k, or if you want to think about distributing a negative 1, I have k plus 1 minus k. Negative 1 times negative 4 is a positive 4. I have like terms, k minus k goes away. I have a plus 1, I have a plus 4. Which takes us just a 5. So I have 5 over the denominator of the 4k squared plus 16k. We could factor this out, but our answers don't have that. So it looks like my answer is going to be an A. All right, 13 and 14 gets a little bit trickier because they are not like terms. This denominator is an a plus 1. This denominator is a 3a minus 2. When you're kind of presented with this, it's almost going to turn into like a cross multiplying problem. All right, let me write this. So we have a denominator, and we know that it has to be an a plus 1, and a 3a minus 2 needs to be down there as well. So one thing I always ask myself, well, what part of that fraction is missing? So if we look at this first fraction, I have an a plus 1. Well, in my denominator, what part is missing? What's a 3a minus 2? The only way to get that there is through multiplication. So I'm going to multiply that first fraction by the denominator of the other part. So in essence, it's almost going to turn into a cross multiplication. So I have 5 times 3a minus 2, which is 15a minus 10. Coming back the other way. So I have a 3 over 3a minus 2, but again, what is missing? The a plus 1, okay? So we have a 3 times the a plus 1. And again, we're going to go ahead and distribute that out. We have 3a plus 3. And one thing, I know it didn't come up in this problem, but this is addition, so it's not going to alter anything, but that is subtraction, kind of like how we did, how I had to handle this last guy. That subtraction needs to be in place for the whole term there, okay? But again, since this is just addition, it's not going to affect anything. All right, so what I'm going to do, I'm going to look to combine something in the top. I have 15a plus 3a, means I have 18a's. I have negative 10 plus 3, which is a negative 7. And we have the a plus 1 over 3a minus 2. Do one of our answers have that? Yeah, we have 18a minus 7 over 3a minus 2 plus 1. And again, it doesn't matter what, multiplication is commutative, so it doesn't matter. So 13 there should be B. I told you adding and subtracting definitely is a little bit more challenging. All right, let's look at 14. 14, common denominator. This is 5a to the third. That already has a 5, so I don't need that, but basically you're asking yourself what does one term have that the other one doesn't. So if this has a 5a to the third, then it has a 5. They have a 5 in common, so I don't need to multiply by the 5. They both have that. What's missing is the 5a to the third. So in essence, this denominator here is the biggest it can get, all right? This 5 is just going to kind of be along for the ride. So if the 5a to the third, and we're keeping 5a to the third, nothing changes from this fraction. So I'm going to hold on to this 6. What is going to change is this fraction. We went from 5 to 5a to the third. When I'm changing that base, whatever I did to the base or the bottom, I have to do to the numerator. So how did I get from 5 to 5a to the third? Well, I multiplied by a to the third. So 4a, right, the numerator of that guy, and I'm multiplying by a to the third. When I multiply bases, I add exponents. So I'm adding 4a to the fourth. And again, I would look to factor. I guess we could pull out a 2, but again, the answers don't yield that. They have a 6 plus 4a to the fourth over 5a to the third. I'd be done there. Okay, can get very, 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 very tricky adding and subtracting them, which also, it's kind of true to form. I think it's most difficult to add and subtract a fraction. Just kind of take your time with them. Remember your rules of adding, subtracting fractions, and just because an expression, it really shouldn't change the game much. Again, always, we have questions. Make sure we are reaching out.